This standard is about solving systems graphically. This video will have two parts. First, we're going to determine whether an ordered pair is a solution to a system of equations, and then we're going to solve a system of equations using a graph. So first of all, what is a system of equations? And that's two or more equations that are considered together. For instance, here's two equations, x minus y equals 11 and 2x plus y equals 19. I want to find a solution to both of those equations at the same time, and I'm going to call them a system because I'm thinking about both of them. So let's think of some numbers that could make the first equation true. What if I said x was 12 and y was 1? 12 minus 1 is 11. So one possible ordered pair for the first equation is 12, comma 1, because 12 minus 1 is 11. Another possible ordered pair is 14 and 3, because 14 for x minus 3 for y would be 11. Now the tricky bit is we need to find an ordered pair that's going to make both the first and the second equations true. So let's look at this first ordered pair, 12 for x and 1 for y. Does that make the second equation true? 2 times 12 plus 1 for y, does that equal 19? I'm thinking not. 24 plus 1 is not 19. The second one doesn't work either. Later on in this video, I'll show you ways to find ordered pairs that would make both of these true. But for now, I'm just going to give you practice at seeing if ordered pair works or not. So I'm going to give you some ordered pairs, and we're just going to plug them in and do the arithmetic. So here we go. 2 for x and negative 3 for y. 6 for x and negative 5 for y. And 10 for x and negative 1 for y. So first let's put in 2, negative 3. 2 minus negative 3 equals 11. This isn't looking good. I'm going to turn this into plus a positive. So 5 equals 11. Nope. So I don't like that one. Let's try the second ordered pair. 6 minus negative 5 equals 11. Plus a positive, this is looking better. 11 equals 11. So this ordered pair works in the first equation. Let's try it out in the second equation. So I have 2 times 6 plus negative 5 equals 19. 2 times 6 is 12 plus negative 5. And that is 7, which does not equal 19. So this one doesn't work either. So teacher logic tells you probably 10, negative 1 is going to work, but let's do the arithmetic and see if that actually works. So let's see, I'm going to make a little box here. So the first equation was x minus y equals 11. So 10 minus negative 1 equals 11. Make that into plus a positive. 11 equals 11. So far, so good. The second equation, 2 times x, which is 10, plus y, which is negative 1, equals 19. 2 times 10 is 20, plus negative 1, that is 19. So of these three ordered pairs, the one that's going to work is this one. That set of x and y made both of those equations true, so this is a solution to the system of equations. Now, how would you find an ordered pair if I didn't give it to you in the first place? So here's a system of equations. I'm not going to give you an ordered pair, but let's see what we can do to figure out what the ordered pair that would make them both true might be. And the way I'm going to do that is by graphing. In this chapter, we're going to learn 3 different ways to do this, but the first one will be with graphing. So these are already in slope-intercept form, so I'm going to go with that. 1, 2, 3. Put a dot at 3. Go up 4, 1, 2, 3, 4 over 1. Up 4, 1, 2, 3, 4 over 1. And it's important when you're doing systems by graphing that you draw a really straight line. It's hard to do on this iPad app, so I'm just going to count backwards and fill in as many points on the line as I can. So I'm going to go down 4, 1, 2, 3, 4, over 1 to the left to kind of keep the pattern going in the other way. 1, 2, 3, 4, over 1, and then 1, 2, 3, 4, over 1. Alrighty, so I'm going to do my best to connect these. Yeah, not that impressive. Let's try the other one. So I'm going to go down to -2 and make a dot. And then now the slope is negative, so that's the same as -1. It's like there's a 1 in front of the x. I'm going to turn the slope into -1 over 1. So I'm going to go down 1 over 1, down 1 over 1. And I think you can see this is probably going to work. If I keep making the pattern go backwards, I'd go up 1 over 1 to the left. It's going to intersect right there. So in spite of the woogity lines, I think you can see that they intersect at this point right here. And that point has an x-coordinate of -1 and a y-coordinate of -1. So let's see if that ordered pair makes both of these equations true. I'm going to put -1 in place of y and see if that equals 4 times -1 plus 3. Does -1 equal -4 plus 3? Yes, it does, because that equals -1. Check. And then let's see if -1 equals the negative of -1 minus 2. So does -1 equal 1 minus 2? Yes, it does, because 1 minus 2 is -1. So check, that works too. So I graph both of these lines, and I look at the place where they cross. That's going to be the point that makes both of those equations true, and I've written the answer as an ordered pair.